In this example, we'll see how using one of the addition formulas or difference formulas in reverse can be super helpful. Let's graph y equals the sine of x times the cosine of 2x plus the cosine of x times the sine of 2x from x equals 0 to 2 pi. Now at first glance, who the heck knows what this thing looks like? I don't know how to graph it in its current form. But let's notice that this is of the form sine of one thing times cosine of another thing plus cosine of the first thing times sine of the other thing. And we have a formula that tells us that's what you would get if you had sine of A plus B. In other words, this thing we want to graph boils down to a sine function where A is playing the role of x and B is being played by 2x. So in other words, we're really just needing to graph sine of 3x. And we know how to do that, right? There's no shifting, either up or down, because there's no addition going on here. The amplitude is the usual 1 because there's no coefficient in front of the sine. And the period is 2 pi over 3. Let's start marking our axes. Since the amplitude is 1, I'll just put a 1 there and there, -1. Let's see, we need to go out to 2 pi, but our period is 2 pi over 3. So let's see, one period will be there, and then one more, another 2 pi over 3 will bring us to 4 pi over 3, and one more of those will bring us to 6 pi over 3, but 6 pi over 3 is the same thing as 2 pi, and that's as far as we need to go. I'm going to dot in lines so that my peaks line up where they should. It looks like those aren't even. Let me just move that -1 down a little bit. I think maybe more like there. I think that's a little better. Okay, and we are graphing a sine graph. So the sine graph starts at the origin, since there's no shifting, and it finishes on the x-axis, and it's going to be on the x-axis halfway between those two, so there, and then it starts out going up, so halfway between those first two dots, I'm going to have a dot up on the 1, and so that's at pi over 6. Then halfway between pi over 3 and 2 pi over 3, we'll have a trough. And let's see, that would be at, what, 3 pi over 6, so that's pi over 2. And then similar pattern for the next couple of cycles that we need to draw. Let's see, this would be 3 pi over 3, so that's a pi. We've got a peak at, what's that going to be, 5 pi over 6. Yeah, and then the next mark will be at 7 pi over 6. And we've got a trough there. Almost done. We've got an x-intercept halfway between 4 pi over 3 and 2 pi. Let's see. 2 pi would be 6 pi over 3. Okay, so halfway between them is 5 pi over 3. And I've got a peak at, let's see, it's going to be some number of 6. 4 pi over 3 is like 8/6. 5 pi over 3 is like 10/6. So this must be 9/6. Okay, but we should really simplify that. So let's see, that's going to be 3/2. Well, I think this is the hardest part of these graphs. And then we must have a, let's see, 2 pi is 12/6. So this must be 11 pi over 6. Yes, because 5 pi over 3 would be 10 pi over 6. Okay, and I've got a trough there. Time to connect the dots. I kind of wish I hadn't made the 1 so high and the -1 so low. This would be easier to draw if I hadn't, but that's okay. We'll deal with it. Remember, these waves are not pointy. You have a rounded top and bottom. Okay, that's a little shaky, but we get the idea. Okay, so that shows how useful these sum and addition formulas can be for being able to graph and just generally analyze some more complicated combinations of sines and cosines.